Hello class, good day. Welcome to so, Statics of Rigid Bodies. So today I'll be discussing Lecture 7, Moment of Force about a Line. Okay, let's start. So let me share my screen. So moment of force about a point in the line. So we have talked about already on the previous lectures what does a moment or what does a force have to do in order for you to have a moment. Okay, the ability of a force to produce rotation or bending or flexure. Okay, so in this case I am holding my cell phone. I have applied a force upward, and then the cell phone rotates about about the axis on my hand, right? Now, let's look on how is it affecting a specific point and the line. So definition of moments. We have identified also that moments are vectors and simply can be solved using a scalar form or in solving the magnitude you are required to have the moment arm multiplied by the magnitude of the force multiplied by the sine of the included angle. So using the right hand rule. Okay? Okay? It's one. So two forces F and F prime are equivalent if and only if they are equal. Equivalent magnitude and at the same time, same direction. And have equal moments about a given point O. So as long as at any point O, they have equivalent moment, the two forces are equal. So in this case, we have moment m naught or m naught prime is equivalent to m naught, and at the same time, F is equal to F prime. It simply implies our Barigdon's theorem. So we have already stated this theorem from the previous lectures that you can simply summarize everything, okay? You can simply summarize everything. So the moment in this case, the moment at point O, about point O of all the forces F1, F2, F3, and F4 can be summarized. So the moment at due to F1 is simply R cross F1, right? Added R cross F2, added R cross F3. By simply adding everything, I can simply get the simple magnitude R, and at the same time, the simple summarized force F, okay? And that will give me the Barigno's theorem. It gave me also the same moment about point O, okay? So that's essentially it is. That's essentially is all about in the Barigno's theorem. Now, talking about rectangular components of the moment of a force, simply the moment of F at point B are the following, right? So we have simply identified this, remember? So this one, right? We have this on the distance formula, okay? So RA minus RB is simply the vector distance between the 2 points A and B, okay? Giving us, this is necessary in order for you to get the unit magnitude, the unit vector, sorry about that, the unit vector at the same time, the uh, the vector component of your moment, okay, the directional vector. So in this case, we have here the following. So your I, J, K are in again, and your distance, and then your forces. Okay? Example, the line of action 90 Newton passes through the points B and C. So we have initial idea here, no? You can simply get the distance from C to B. Okay? And then uh, A to B, and then B to C. C to B and A to C. Okay? So this is a typo error, no? Sorry about this. So this should be R uh, RAC. Okay, RAC. And this one, RAB. What is the moment of F about point A, and what is the perpendicular distance from point A to the line of action of F? Okay, solution. So, getting first the distance. Okay, we have identified that from this one. Point B minus point C, or point C minus point B. So that will be 0 minus 4. Where's that coming from? So 0 minus 4, 7 minus 11, 7 minus 0. Okay? So that will be my RCB. Okay, RCB. So dividing this vector by its magnitude, we simply get the unit vector. So I hope you already can compute for the unit vector from the previous lectures. You may review the previous lectures, or you can comment down in this video if you have any questions, or to be you need some clarifications. I can easily explain it to you, class. So the unit vector is simply the magnitude multiplied by the unit vector, okay? Giving us the force vector, the following: negative 40 I hat, negative 40 j hat, and positive 70 k hat. Now, how about from B to A, or the distance? Simply getting the position vector, or the distance vector. 4 minus 5, 11 minus 0, 0 minus 6. So let's identify it. Where does it coming from? Where is it coming from? So this one, right? So from B to A, 4 minus 5, 11 minus 0, 0 minus 6. All right? So that will be that one. 4 minus 5, 11 minus 0, 0 minus 6. So the moment arm, or the position vector from B to A, or A to B, is simply negative 1 I hat plus 11 j hat minus 6 k hat. And simply computing for the moment, just simply doing your Kramer's rule again. So I'm computing the moment arm. So giving us the following. Okay, very straightforward. Okay. So alternative choice of position vector, you may also use A to C, since we will have the same moments at point A. Okay, take note of that. So if we say that uh, they will have, or the force have the same moment, will have the same moment in space at this point A. Thus, it means the moment about point A along, because of this force along this line, will be the same. Okay, from the Varignon's theorem. So thus, we can simply get uh, alternative choice of position from A to C. Simply get the position vector. So the same approach from the initial solution. And solving for the moment. So the same, okay? So magtaka kayo pag magkaiba yan, no? Mali kayo, ibig sabihin nun. So it's the same, equivalent. The moment, because of a line, the moment of a force about a line, okay, will be the same all throughout. Okay, now solving for the perpendicular distance. So from this, bakit ganito to? Okay, simply solving for the magnitude, because you are getting here the moment arm. Okay, take note of that. So magnet moment is equal to F cross R, R cross F, right? Giving us the following. So simply solving for the magnitude. Magnitude lang naman hinahanap eh. That's why you are not required to have the cross product. Okay. So the perpendicular distance, you're talking about the distance, is a scalar quantity. Okay. So scalar quantity giving us R to be, or the perpendicular distance to be 8.66. Okay. Next example. Cables in A, B, and AC extend from an attachment point on the floor to the attachment points B and C in the walls. The tension in cable AB is 10 kilonewtons and the tension in cable AC is 20 kilonewtons. What is the sum of the moments about O due to the force exerted on A by the two cables? So, okay, hindi ko naintindihan yung problem. Ulitin natin. Charot. O, sige. Cables AB and AC attached at point A. The tension in KB is given at 10 kilonewtons. So, this one have a 10 kilonewton force. So, you can simply get the force vector, right? By simply getting the unit vector first and multiplying by the magnitude, right? multiplying or getting the magnitude. So the magnitude is given 10 kilonewton, and then multiplying it the unit vector from the position vector A to B, okay, or B to A. And the tension in cable AC is 20 kilonewton. Same in this one, on cable AC, 20 naman, okay? What is the sum of the moments about O due to the force exerted on A by the two cables? Let's look on the solution. So same approach, position vector from AB and AC will be computed. Okay? So in this case, the unit vector is the following. Now multiplying this by the magnitude 10 Newton, 10 kilonewton. So, yun, no? Power. So, gets, kuha na natin yung force vector at AB. Now, how about force vector at BC? What will be this one? So, same approach, getting the position vector or the unit vector first from A to C. Then at the same time, multiplying it by the magnitude 20 kilonewtons. So, FAC, simply that one. Okay? Now, what will be, ano nga hanapin natin? Ano ba hanapin natin? What's the sum of the moments about O? So, by simply getting, where is O? Origin, okay? About this one, no? About, because of the two forces. So, you can simply get the moment arm for both forces, okay? So, that will be RAO, and then, or simply, ito yung distance na yun from the origin to the point A. So, simply getting it, adding the two. Okay? So, application ng Barigdon's theorem kanina. So, medyo kulang to, no? Dapat may parenthesis dito para malinis. Okay, this should be from Barigdon's theorem. So, you have a force vector, you have a moment arm. Ito yung moment arm mo, or position vector from the origin to the point A. Okay? So, simply solving, you can get the, or summing up everything, you will get the moment at point O. Or you can simply add the two forces, force AV and AB, sorry about that, and force FAC, and then cross product with the moment. All right? Now, finally, last example. A force 800 Newton acts on a bracket as shown. Determine the moment of the force about point B. So, I think this is a book problem, no? This is a book problem. The moment MB of the force F about B is obtained by forming the vector product. So, simply RAB cross F. So, in this case, 800 Newton. Okay. So, very straightforward. The distance from A to B. Cross product with the force vector, 800 Newton. Ano to? Cosine 60 degrees and then sine 60 degrees. Kasi yun yung force vector na ito. Right? The X and Y components niya. So, parang nagkaroon tayo dito ng, ito yung kinukuha natin. This is the unit vector. Okay, the unit vector. So, you can factor out first 800 tapos yung cosine I. The cosine I and the sine 60 degrees J is simply your unit vectors. So, giving us the force to be that. And then simply solving for the moment. Very straightforward again. Moment arm, this one, crossed by the force. Boom! Negative 2.6 kilonewton. Makes sense, right? Out to the page. Or into the page. Into the page. So, you have a moment or the arm. And then force the pupunta sa taas. Then into the page yung moment. So, negative. Okay? Now, about scalar product of two vectors. It's simply the dot product. No? Ito yung tinatawag na dot product. So, commutative, distributive, and in terms of components, if P and Q are equal, you can simply have scalar multiplication or P squared. Right? Applications of the scalar products. The angle formed by the two given vectors. So, obtain an equation for the angle theta in terms of the components of vectors. Simply the following. In order for you to get the angle in between. So, kapag given yung two vectors. Alright? So from the projection of a vector on a given axis, consider a vector P forming an angle theta with an axis or directed line OL. Kasi merong application to. This will have an application for us on moment of force about a line. Okay, and then at the same time, in decomposing, okay? Decomposing moment systems, force composed systems. So, projection. Okay, so you can easily project the component of the force on that direction, on a given axis. Okay. So in this case, using that product to determine an angle, what is the angle in between the line AB and line AC? In this case, line AB and line AC. So this one, we have two lines, right? Pero yung line, the line will have magnitude of forces at the same time you will have force vectors. So you can easily get the angle in between by using the dot product or the scalar product. Okay? Let's look on this. So, getting the position vectors, basic na to, no? We have already identified the 6, 1, 2, negative 2. So, 6 minus 4, 1 minus 3, negative 2 minus 2. For the position vector, RBA, and for RAC, RCA is simply that one. 8 minus 4, 8 minus 3, 4 minus 2. Okay? So, basic. Chicken pit out. Okay? Next. Their magnitudes are equivalent of the following. Okay? From the Pythagorean theorem. Tama? Correct. Okay? Next. So, simply getting the dot product or getting the dot product. So, ito lang yon, no? 2 times 4 plus negative 2. So, ina-add mo, 2 times 4, negative 2 times 5, negative 4 times 2. Yun lang yun. Okay? And simply summing up everything. So, ito yun. The dot product, yun, is 1. So, negative 10. And then simply getting the magnitude of the two position vectors and getting the arc cosine, simply will give us 107.7 degrees, which makes sense, no? The angle is obviously above 90 degrees. Above your 90 degree, your right angle. Okay? Putek, ang dami ah. Okay. Suppose that you pull on the cable OA exerting a 50 Newton force at O. What is the component of F parallel to the cable OB? So in this case, we will have a 50 Newton magnitude at OA. So origin and A. Okay. So you can get the position vector again. This is 0, 0, 0. Take note of that position, origin position. What is the component of F parallel to the cable at OB? So kukunin natin the component of F parallel to cable OB. So our approach, getting first the position vector at RA and getting its magnitude. And where's this coming from? From the unit vector, okay? From the unit vector. So divided by its magnitude, you will get the unit vector. So multiplying this, or rather, sorry about that, we will get here the position vector B to O. So this one, right? So 10 minus 0, negative 2 minus 0, and 3 minus 0. So ito yan. And then getting its magnitude, Pythagorean theorem, and then multiplying or dividing this both, or this magnitude dividing this one will give us the unit vector. Okay? And then for us to identify the force in parallel or in terms of component, taking the dot product of the unit vector B to O and F will give us 200 or 20.4 newtons. Okay? But let's talk about first nung F. So, simply multiplying by the magnitude given naman yung 50. So, this one. This one. 50 newton at OA. Okay? The parallel component of F is simply the following. Ito na, no? That product multiplied by the scalar multiplication. Now, what's the essence of this? What is the essence of this? Actually, it's the mixed triple product. Okay, yan na. So, the mixed triple products of three vectors is simply the following. The P dot Q cross R. So, in terms of components of the vectors, we have the following. So, simply doing the cross product first in order for you to get the moment at the same time. Once you get the moment, you get the scalar multiplication or scalar product. Boom! So what's the application of this? Or in determinant form, interchanging any two of the vectors in the mixed triple product changes the sign but not the absolute value of the result. So some application or some properties. Take note negative R to class. The mixed triple product also is the volume of the parallelepipede. Okay? Galing. So as I said earlier, it will give us an insight of the moment of force about a line and application of the mixed triple product. So in this case, we have a force and the moment or R cross R from a given force giving this moment. In order for us to project or the moment at P, we can simply get ML as a projected moment from the unit vector, that product of the unit vector, and ito rin yung kanina, no? That product multiplied by the scalar product of the unit vector of the L. So the mixed triple product can be expressed in determinant as of the following. Notice that the value of the above formula is a scalar which determines the magnitude and direction of ML relative to E. Okay? So from here, we are to determine the moment of a force about an arbitrary line AB. So the moment, so yung application nito is the mixed triple product, again class. First, we need to identify the moment at the moment of F about point A, okay? At tapos, tsaka mo siya ipoproject up to the line AB, okay? So cross product first and at the same time after nun that product, then multiplied by the unit vector. So we are to identify the moment about point AB. So how we can do that? Getting first R, saan galing to? Ito yun, no? Position vector 8 minus 2, 6 minus 0, 4 minus 4. So R 6i plus 6j. And getting the alam na pagkakasunod-sunod. We already have an idea. The moment of F is simply R cross F, right? Giving us MA. And then finally, in order for us to determine the magnitude of BA, simply get the position vector. Dividing it by its magnitude will give us the unit vector, the position vector, right? The unit position vector, unit vector. Now, this will be important later sa final multiplier. But for now, we can simply get, or ito rin pala yung gagamitin for the dot product. Okay? So, dot product, EBA cross the moment. So, the moment a while ago, we have already identified here. So, E dot MA. So, simply multiply each component and then add. So, scalar yung lumabas. This is a scalar quantity. Paano mo siya, sir, moment tayo kapag pag moment, vectors, right? But why this is scalar? But wait, there's more. because you will have later a simple scalar multiplication. Okay, so scalar multiplied by a vector is simply a vector. Take note of that. So that will be, summing up everything will give us 109 and multiplying again by EBA. Ito yan. Right? So this one, EBA, this one. Okay, so give us the following. ML simply 109 EBA. Okay, example 22. How about what is the moment of force F about the bar BC? The bar BC. So get position vector AB, basic. You know, this one. Oh. So the force F about BC. So get first the moment of F about B. So nakuha na natin si RAB, simply next RAB cross F basic. Tama? Tingnan natin. Ayun, no? Ay, sorry. Kinuha niya muna si RCB. Sorry about that. So ito, in order for you to get the position vector of RCB and later the unit vector. Okay, the unit vector. In order for us to assess the final moment about line BC. Okay? So the magnitude at RAB, ano to? Typographical error again. Sorry about this, class. Sorry about this. So this should be ECB. No? Naantok na Sir Bogart eh. Sorry. Okay, so RCB is simply, or you get the unit vector. So for now, get the moment. Ayaw kunin yung moment. Ayun, no? RAB cross F. So simply get the moment and then that product by the ECB, which is a while ago here, this one. Okay? So give us the following. So I hope you learned something today, class. That will be it. Moment of force about the line. Then the mixed application of the mixed triple product. God bless you all, and if you have any question, comment down on this video or message me personally in my email or in my Facebook accounts. Thank you all.